of course, we'll all follow this now. So here is the question. Now this looks very similar to the question I asked earlier. So here is the question. We again have grids, okay? So there are certain dots. 1, 2, 3. Let's take 3. Okay. So you have one like this, 2. Okay, so just give me 1 second. Maybe we can just start with very small case. Yeah, you start like this. Okay. Let's see. So now in this one, we have certain dots in a rectangular grid. So Raghav, the question is how many ways you can go from the start to the end. Okay, and the rule is that at every step you have to go to the right or you have to go up. That is a rule, okay? Every step go right or up. But yeah, this is not the question which I had asked, so I'll say what the exact, and you cannot cross a certain line. So there is this line which we cannot cross. So you have to always stay below this line. So now it's a new question for everyone, and this is very interesting for a certain reason. Okay, never go above the diagonal. An example would be like, playing it very safe. You can take an example like just going like this to here, then up and then up. Raghav, you see, this is one example.
Yeah.
Okay, this is one example. What I want to know, what I want to know is how many such paths are there in total?
Okay.
Yeah, so Adityan, this is a slightly different question. Okay, so let's see.
How many such? There? Two.
How many such paths are there? 2 paths. Okay, so Adityan is saying 2. So Adityan, what are your 2 paths then? The green one I have drawn. What is the other one?
The other one is like that, like that, like that, like that.
Right, and there are no other paths.
Yes.
You sure about that? Yes, right. So this gives the answer is 2. So maybe what I will do for this is I'll take, I'll again note it down here, maybe in the corner here, for n equal to 2, because it's 2 comma 0. There are 2 steps available on both sides. For n equal to 2, the answer is 2.
Two.
Okay, let's see. So I hope this is this clear for everyone else? It's quite clear, right? There are no other choices. Okay, if so, I'll just go with the flow, and if someone has any question, just interrupt me. Okay.
And if n equals 1, then it's going to be 1.
Yes, you're right. N equal to 1 is 1. That's correct. Okay, now see, y'all might be thinking that this seems like a repetition of the previous question with just a new rule, but we will be surprised a bit in the end. Let's see. So let's try to figure out this one. Now, same question is same. Yeah. So just figure it out. Okay. I'll just start drawing a few of them. Few obvious ones. This maybe this. Yeah. So did we get 5 then?
Yes, sir.
5 paths, right? So which one am I missing? Can you tell me?
Mm,
Or you can just tell your
thi-
5 paths, anyways.
this one.
No, again, yeah. Again, see, you cannot go to the left. This is again what Karthik had also pointed out. Once you go right here, you cannot go to the left. That's not allowed. Okay. So, yes, that's not allowed.
So we can't cross the slanting line that we have made.
Yeah, we also cannot cross that. And also, Raghav, you should also, which Karthik has made a mistake, sorry, Adityan is making a mistake with, is he's saying you can go like this, and then he's going to the left, and then no, this is not also not allowed, because again, we cannot go to the left, only right or up. So this condition
Sir,
here is very important.
sir,
Yeah.
sir, I know how to do it. So first we need to go to the right.
Uh-huh. Okay.
Some another one.
What's the other one?
Like one more right.
Uh-huh. Okay.
Go up.
Mm-hmm.
Up. Right.
Hmm. Right. This one
Up.
I was missing. Yeah. Okay. So Adityan, you see, right? With this, we have 5.
Sir, did you do this one also? Just asking.
Yeah. Yes, I think I did this. Yeah. So in total, if you just draw all of them, you will see that it will be 5. Yeah. So that
So when
and whatever. Yeah.
when n equals 3, is it it's 5.
Yes, it's 5. So we can safely say that, okay? I mean, if someone is asking you to prove it, then you can just draw all the 5 of them and show it to them. Not a problem, right? We can do this, right? N is equal to 5. Okay. So similarly, for homework, you people can try to do it for n equal to 4 and check that the answer will be 14. Okay. And for n equal to 1, the answer is 1. Okay. Now, what is interesting about this example? We have not done this example before, okay, in some sense, but from the previous class, or if people have watched the video, do you remember this number, this pattern, 1, 2, 5, and 14? Have we seen this somewhere else?
Sir, hexagon.
So you see, he's realizing, yes, yeah. Adityan, can you expand on that? Or for Karthik, you have seen the video. Have we seen this pattern before? Yeah. So what Raghav is saying is that the number of ways to triangulate a hexagon, the number of ways to break a hexagon or divide a hexagon into triangles was 14. Yes, Adityan? Yeah. So if you remember, if to break a hexagon, number of ways to divide a hexagon into triangles was also 14. And then for a pentagon, the answer was 5, right? And for a quadrilateral, the answer was 2. And for a triangle, the answer was 1. Ooh, so this sequence of numbers seems to be matching with this. Okay. So does everybody see the pattern, right? Now you see, from here we can say the following. If I tell you, let's say I tell you that for heptagon, means for 7-sided, this is 7-sided, it's called heptagon, just a name. Okay, for heptagon, number of ways to triangulate is equal to 42. Let's say I told you this, and even you can check maybe. Okay, though it will be a little tedious to check unless you find a good way to break it into similar, break it into classes which look the same and so on. But anyways, eventually we'll develop a formula for all this. Is 42. Then if I ask you the question that for this, let's say that if there are 5 points, 1 2 3 4 5, and here also 1 2 3 4 5. Okay, and let's say I just marked all these. Okay, if I marked all these points, okay, then again if I ask you the question, number of ways to go, number of paths to go from the starting to the stop, this is 0 comma 0 and this is 5 comma 5, number of ways to go from 0 comma 0 to 5 comma 5 without crossing the diagonal. Okay, then you would guess that the answer to this should also be 42. Is that right? Okay, because these two problems are having the same answers till this point. So for the next one also they should have the same answer, right? So this is one example where two different problems which look very different have the same answer. Okay, it means that there is a common technique which we can use to solve both the questions. Okay, and this is called the bijection principle of combinatorics. Okay, so we will do this in more details later. Okay, but just for the curiosity, and because this is really exciting, at least when I saw it for the first time, right? Two problems which look very different, okay, their answers turn out to be the same. So when we see this, then we will later try to develop techniques in which we will show why they are not so different. We'll try to connect these two, problems. With every path, we will draw a triangulation. And for every triangulation, we will draw a path. And so we can establish properly that the numbers have to be same. Okay. So yeah, that was the first section of today's class, what I wanted to do. Okay, trying to show similarity between two different kinds of counting problem. Okay, and we'll see how combinatorics is useful here in providing the same method for both of them.